In this video, we will talk about translating the graph of an exponential function to the right, to the left, up and down. So when a graph is translated, each of its point is shifted the same distance in the same direction. So I think on your homework, you'll be able to you'll have a graph, right? You're gonna have a graph and you'll be able to drag it, click and drag it to whichever direction. So that's easy for you, but if I have to do it by hand, I will have to move all the points to the same direction and the distance. So first of all, how about horizontal translation? Now take a look. If you are adding or subtracting a number in the exponent, it's going to look like that. If you're adding a number in the exponent, so for example, if you have y equals 2 raised to the x plus 5, okay, you notice that plus 5 is a tiny little number written as an exponent, okay, right? It's adding to the exponent, right? I keep saying the same thing again, I'm sorry. But say that this happens. What will happen is the graph will shift 5 units to the left. Okay, another one. If you have y equals 2 raised to the x minus 5 this time, guess what? The graph will shift 5 units to the right. Okay, and this is different from something like this. Y equals 2x. And then if you have a big plus 5 outside, if you have that, the graph will shift 5 units up. And if you have y equals 2 to the x power, and minus 5 is written big, it's not part of the exponent, this graph will be shifted down 5 units. So depending on where the number is and whether it is being subtracted or added, that makes all the difference. So, but I'm not really going to stress over this too much because you've seen this transformation rule before. You've seen this in section 1.6. So you know this already. So let me fill in some blanks and look at some application problems with you, or just examples with you. So first of all, to graph, let me see, what's the first one? First of all, to graph y equals b raised to the x plus h power, we shift the graph of y equals b to the x power to the left h units. If it's adding in the exponent, we're going to go to the left that many units. If it is subtracting, okay, we're going to go to the right h units. It almost feels opposite, doesn't it? Like if you see a plus, don't you want to go to the right? I do, but it's really the opposite. If you see an adding a number in the exponent, you're going to go left that many. If you see subtracting h, then you're going to go, and that h can be any number. If you see like subtracting 5, you're going to go 5 to the right. Now, if you are down at, if you're no longer in the exponent, but now you're just adding a number to that exponential term, like that plus 5 or that minus 5 is written big and not part of the exponent, this will just move the graph up and down. So adding k will shift, okay, I have to read this carefully. We shift the graph of y equals b to the x up k units. And if it's subtracting, we're simply going to just move it down k units. So I'm going to look at those examples very carefully. But I know you guys saw this transformation rule, translating rule in section 1.6. So I know you've seen this before. All right, here. Example, describe the transformation of g of x. Let me write this g of x big. G of x is 2 raised to the x plus 5, and the minus 4 is outside. So guess what's happening here? That plus 5, this plus 5 shifted the graph 5 units to the, look, it was adding, so left. First of all, this graph is getting shifted 5 units to the left. Now, what's that minus 4 going to do? This subtracting 4. Okay, this will shift the graph down 4 units. So we describe the transformation. And then they say identify the domain and range of g of x. Well, listen, you know this. Domain is always going to be all real. So domain doesn't change. So I'm going to say domain is from negative infinity to positive infinity. For exponential function, that's always true. But range is now different. Now, the default range, I really call it default. I'm sorry. How do I spell default? I think that's what it is. Default range is from 0 to positive infinity, isn't it? Where did we talk about that on this table? For an exponential function that doesn't have any vertical translation, we didn't move it up or down at all. The range is from 0 to positive infinity. And you saw that by graphing a couple examples with me. Okay, the horizontal asymptote was at y equals 0. The horizontal asymptote was at y equals 0 when we don't move it up or down at all. But notice we moved this graph down 4 units, right? So because the graph went down 4 units, the range got shifted down 2. So the range is not going to be from 0 anymore. The range is actually from negative 4. And we can maybe add one extra thing. We can say that the horizontal asymptote is at y equals negative 4. So that was just some extra thing that I wanted to add. But because the graph got shifted down 4 units, the range is no longer 0 to infinity, but it is negative 4 to infinity. So that was important here. Let's do one more example. This time, let's describe the transformation of g of x equals 3 over x raised to the x minus 2 plus 5th power. Let me write this big. G of x. The base is 3/4. That means this is an exponential decay function. I have x minus 2 and subtracting 2 right here will move the graph, shift 2 units to the right. So we describe the horizontal translation. And what about this? Adding 5. Written very big. This is going to shift the graph up 5 units. Okay, so let's talk about the domain and range now. You know about the domain. Domain is always going to be positive infinity to negative infinity for exponential functions. So I'll write that down. Domain is negative infinity to positive infinity. Now range though, the default is 0 to positive infinity, but you see how this function got shifted 5 units up. So the range is no longer 0 to infinity, but 5 to infinity. That's it. So if I want to add one more thing, how about that horizontal asymptote? We have a horizontal asymptote at y equals not at 0, but y equals 5 because this graph is shifted up 5 units. So the range changed and the horizontal asymptote also changed from that the parent function. I think I noticed a tiny typo here. Maybe you can change the name of this function to g of x for me and everything will be perfect. So that is enough. That is it for translation of exponential functions.